Hi guys, welcome to today's tutorials. Today we'll be looking at mathematics past question papers on JUPEB. Get your writing materials ready with your calculators. We'll be right back. Find the non-zero negative value for x which satisfies the equation. In solving this, we'll find the determinant of our matrix x1 0, 1 x 1 and 0 1 x equals 0. Okay, so we'll expand this a little bit for us to find our determinant. This become x1 0, 1 x1, 0 1 x, and x1 0, 1 x1. Now, for us to find our determinant, we'll multiply this through. This becomes x times x times x. Multiply this through, this becomes plus 1 times 0, and multiply this becomes plus 0 times 1 times 1. Okay, now we subtract minus this is 0 times x times 0 minus x times 1 times 1 and minus this 1 times 1 times x. Okay, opening up this, we are having this as x cubed plus 0 plus 0 minus 0 minus x and minus x. So this leaves us with x cubed minus 2x, okay, equals 0. Now solving this out, what's common here is our x. We have x, bracket open, x squared minus 2 equals 0. So factorizing this will give us x equals 0 or x squared minus 2 equals 0. So taking our 2 over to the other side, our x squared becomes 2. So our taking square root of both sides, x equals to plus or minus root 2. So the value of our answer will become plus or minus root 2. So for our non-zero negative value will give us minus 2, minus root 2. If z equals 233, 410, and 140, find the determinant of z. Now we are going to write it as 233, 410, 140. Okay, now taking these two rows over to this, we are having 2, 3, 4, 1, 1, 4. Okay, this will now become multiplying this we are having 2 times 1 times 0 plus multiply this, we are having 3 times 0 times 1 plus multiply this, we are having 3 times 4 times 4. Okay, minus multiply this, we are having 3 times 1 times 1 plus this, okay, minus 2 times 0 times 4 and minus 3 times 4 times 0. Okay, 2 times 1 is 2 times 0 is 0 plus 3 times 0 is 0 plus 4 times 3, 12. 12 times 4, 48. So we have plus 48 minus 3 times 1 is 3 minus 0 minus 0. So this will leave us with 48 minus 3, which brings our answer to 45. So the determinant of z would be 45, which is option B. Compute 1 plus 3 over 1 plus I all squared. Now in doing this, first off, we'll multiply this fraction with the conjugate of our denominator. So in doing this, we're having, okay, let's work out this first. This will be 3 over 1 plus I times 1 minus I, which is the conjugate of this, and 1 minus I. Okay, so if we solve this out, this leaves us with 3 brackets 1 minus I all over 1 squared minus I squared. Okay, so this will give us, just to be sure, 1 plus I, 1 minus I. This is 1 squared minus I plus I minus I squared. So this cancels, leaving us with 1 squared minus I squared. That's how we got this. Okay, so this, expanding this gives us 3 minus 3I all over 1 squared. We know that in vectors, I squared equals minus 1. Okay, I squared equals minus 1. So substituting that value here, this becomes 1 minus 1, which leaves us with 3 minus 3I all over 2. Okay, now we are going to replace this value for this. All right, so this becomes 1 plus 3 minus 3I all over 2 all squared. Okay, this, expanding this, we are having our LCM here as 2. Okay, 2 here, 1 here, 2. This will be 2 plus 3 minus 3I all squared. So this will give us 3 plus 2 will give us 5. This brings us to 5 minus 3I all over 2 all squared. Okay, so if we square this, we are going to have 5 minus 3I over 2 times 5 minus 3I over 2. Okay, this times this will give us 25. This and this will give us minus 15I, and this times this will give us minus 15I, and this times this will give us plus 9I squared all over, this times this will give us 4. Okay, collecting our like terms, we are having 25 minus 30I plus 9I squared. But recall that our I squared equals to minus 1. So imputing it here, this becomes all over 4. So this becomes 25 minus 30I plus 9 minus 1. So this will give us a minus 9. 25 minus 30I minus 9 all over 4. Okay, now 25 minus 9 would give us 16 minus 30I all over 4. All right, now if we solve this, if we have this, we are going to, this division, this 4 can be shareable to both sides. So this becomes 16 over 4 minus 30I over 4. So we can break this down to give us 4 into 16 will be 4 minus 4 into 30 will leave us with 15I all over 2. So this brings our answer to 4 minus 15 over 2I, which is option B. Find the center and radius of cycle 8x squared plus 8y squared minus 24x minus 40y plus 18 equals 0. All right, in doing this, we'll first of all divide this equation by 8. So this becomes 8x squared over 8 plus 8y squared over 8 minus 24x over 8 minus 40y over 8 plus 18 over 8 equals 0. So this will give us x squared plus y squared minus okay, at this point, let's move our coefficient over to this other side. This becomes x squared, collecting our like terms, minus 3x plus y squared minus 5y equals minus 9 over 4. Okay? So from here, we can apply completing the square method to both parts. So in doing that, we'll half our coefficient of x and square the half of it and add to both sides. Same thing with y, half the coefficient of y squared, add to both sides. So for x, we are having our coefficient as 3 over 2 all squared, which will give us 9 over 4. And for y, we are having our coefficient as 5 over 2 all squared, which will give us 25 over 4. Okay, so for x, we are going to add 9 over 4 here. This becomes x squared minus 3x plus 9 over 4 plus y squared minus 5y plus 25 over 4, which will give us, to this side, we're adding both of these, minus 9 over 4 plus 9 over 4 plus 25 over 4. Okay? Now, bringing out our squares, we are having this as x squared plus x squared minus 3 over 2 squared, which represents this, plus our y squared minus 5 over 2 squared, which represents this, equals, this cancels this, leaving us with 25 over 4. So this, we can write this as x minus 3 over 2 all squared plus y minus 5 over 2 all squared equals 25 over 4. Now to find our radius, our center and radius, we'll use the formula x minus a all squared plus y minus b all squared equals the square root of radius. Now, from this equation, we can see that our a equals 3 over 2 and our b equals 5 over 2, while our radius will become root of 25 over 4, which gives us 5 over 2. So our center and radius will be 3 over 2, 5 over 2, and 5 over 2, which leaves us with option D. Given the equations of the ellipse as x squared over 2 plus y squared equals 1. Now, writing it in a standard form, we are having it as x squared over a squared plus y squared over b squared equals 1. Now, comparing this to this, we'll find out that our a squared equals 2, which leaves our a to be root 2, and our b squared equals 1. Okay, now our eccentricity formula gives us our e equals x squared over a squared. X equals e over a. Our eccentricity equals root 1 minus b squared over a squared. All right, now our b is 1 and our a is 2. So this leaves us with root 1 over 2, which in turn will become 1 over root 2. All right, now our x equals plus or minus a over e. Okay, now our a is root 2 and our e is 1 over root 2. Okay, so if we multiply this through, this becomes root 2 over 1 times plus or minus root 2 over 1 times root 2 over 1. So this becomes plus or minus 2 times 2 will give us plus or minus root 2. So our answer for this will become plus or minus root 2, which is option B. Find the gradient of the curve y equals x cubed minus 6x squared minus 11x minus 6 at our point for x and y is 1 and 0. All right, now first off, we'll differentiate this. If we differentiate this, we are having 3x squared minus 12x minus 11. Okay, now here we'll now substitute our value of x. Here will be when x equals to 1, this becomes 3 bracket 1 squared minus 12 bracket 1 minus 11. So this will give us 3 minus 12 minus 11. So 3 minus 12 minus 11 will give us 3 minus 1, which will give us a 2. So our value of x will become 2, which is option D. Find the gradient of the curve y equals x cubed minus 6x squared minus 11x. Okay, so if we differentiate this, we are having it as 3x minus 12x minus and plus 11. Okay, now when x equals 1, this becomes 3x squared, sorry. This becomes 3 bracket 1 squared minus 12 bracket 1 plus 11. Okay, so this will give us 3 minus 12 plus 11. Now 3 plus 11 will give us 14. 14 minus 12 will give us 2, which gives us option D. Let P be the set of prime factors of 42 and Q the prime factors of 45. So if we have P as prime factors of 42 and Q as prime factors of 45. Now we are going to find for factors of 42. For factors of 42, we have 42 and 1. So we have 1 and 42. We have 2 and 21. We have 3 and 14. We have 7 and 6 and 7. And for the factors of 45, we have 1 and 45. We have 3 and 15. We have 5 and 9. All right. Now, so out of all these factors, which of them are prime? For our prime factors here, we have 2, 3, and 7. While for this, the prime factors, we have 3 and 5. Okay, now the question says we should find P intersection Q. P intersection Q simply means what's common to both of them, and what's common to both of them will be your 3. So our answer will be 3, option B. A polynomial 2x cubed plus ax squared plus bx minus 1 has a factor x minus 1, and the remainder when it is divided by x minus 2 is minus 4. Find a plus b. Now, since we're looking for a plus b, okay, well, first of all, substitute our factor into this polynomial. Our p1 when x equals to 1, okay, will become 2 bracket 1 cube plus a bracket 1 squared plus b bracket 1 minus 1. Okay, this will give us 2 plus a1 plus a plus b minus 1. Okay, so this will now give us equals 0. So this will give us a plus b plus 1 equals 0. So our a plus b equals minus 1. So the value of a plus b will be minus 1. Solve the equation log 3x plus log x3 equals 10 over 3. Now, in solving this, we'll recall that if we have log AB, we can rewrite it as 1 over log BA. Okay, now applying this formula to any of this, we are going to have this as log x3 to be, okay, log 3x, let's use this, to be rewritten as log 1 over log x3. Okay, now substituting this for this, we are having it as 1 over log x3 plus log x3 equals to 10 over 3. Now let's say, let y equals to log x3. So we can write this to be 1 over y plus y equals 10 over 3. Okay? Now, from this point, we can multiply all through by y, okay, to eliminate this. This will give us 1 over y times y plus y times y equals 10 over 3 times y. So this cancels out, leaving us with 1 plus y squared equals to 10y over 3. So multiply through by 3 too to eliminate this. This becomes 3 plus 3y squared equals 10y. Okay, forming this into a quadratic equation, this becomes 3y squared minus 10y plus 3 equals 0. Quadratic formula, which says our x equals minus b plus minus root b squared minus 4ac all over 2a. From here, from this equation, our a is 3, our b is minus 10, and our c is 3. Okay, substituting these values into this equation, we are going to have it as minus 10 minus 10 plus minus root minus 10 squared minus 4 times A, which is 3, times C, which is 3, all over 2 times 3. Okay, this will give us 10 plus minus root 100 minus 4 times 3, 12. 12 times 3, 36, all over 6. Okay, so 100 minus 36 will give us 64. So this will leave us with 10 plus or minus root 64 over 6, which is 10 plus or minus 8 over 6. So our x would be, our x will give us 10 plus 8 over 6, or 10 minus 8 over 6. And 10 plus 8 will give us 18 over 6, or 2 over 6. So this will leave us with 1 over 3 and 3. So x equals to 3 and 1 over 3. Now back to our question. Now you can see that the value of our y in this question will become 1 over 3 or 3 or root 1 over 3. Now substituting back into this, where we have y, let y equals to log this. Okay, so substituting back into our equation, where we have y equals log x3. Okay, now substituting back into that equation, so where our y will give us what? X. Remember that if we have log n equals to b, this can be rewritten as n equals to a raised to power b. Okay, so rewriting this, we are having this as our 3 equals y, x raised to power y. Okay, now for our value of 3 will become our x will give us 3, which is y. Our value of y here is 3 raised to power 3, or 3 raised to power 1 over 3. Okay, now this gives us our x will give us 3 raised to power 3 is 27, or our cube root of 3, which brings us to our answer D. Solve the equation. Root 2x plus 3 minus root x minus 2 equals 2. Now in solving this, we'll move this over to this. This becomes root 2x plus 3 equals 2 plus root x minus 2. Okay, now we'll square both sides. This becomes 2x plus 3 equals 2 plus root x minus 2 squared. Okay, now expanding this, if we expand this, we are having it as 2 plus root x minus 2 and 2 plus root x minus 2. So this and this will give us 4 plus 2 root x minus 2 plus 2 root x minus 2 plus x minus 2. Okay, now this will give us 4 plus 4 root x minus 2 plus x minus 2. This leaves us with 2 plus 4 root x minus 2 plus x. Now replacing this with this, we're having it as 2x plus 3 equals 2 plus 4 root x minus 2 plus x. Okay, moving our common terms one side, this becomes 2x plus 3 minus 2 minus x equals 4 root x minus 2. Minus 1 will give us x, 3 minus 1 will give us plus 1 equals 4 root x minus 2. Okay, so if we square both sides, this will give us x plus 1, x plus 1. Now expanding this, we are having it as x squared plus x plus x plus 1, which will give us x squared plus 2x plus 1. Okay, now having this, we're going to rewrite it as x squared plus 2x plus 1 equals 4 squared is 16, and square root of this will leave us with 60x minus 2. Okay, now expanding this bracket, we're having it as x squared plus 2x plus 1 equals 16x minus 32. Collecting our like terms, we are going to have x squared plus x squared plus 2x minus 16x plus 1 plus 32 equals 0. So this will leave us with x squared minus 14x plus 33, which will give us 0. Now we can now factorize our quadratic equation. Now if we factorize this, this will give us 33x squared. So factors of 33 that can give us 14 will be 11x and 3x. Now we'll consider the signs. Since this is positive, okay, and this is negative, both will become negative. Minus times minus will give us a plus. Minus plus minus will give us our negative 14. So this will now become x squared minus 11x minus 3x plus 33 equals 0. So we group these two. What's common here is x. So if we remove one x from here, we have x minus 11 minus what's common here is 3. So if we remove 3 from here, we have x minus 11. So bringing these two out, this becomes x minus 3 equals 0. So therefore, x equals 3 and x minus 11 equals 0. So therefore, our x equals 11. So the factors of x will be 3 and 11, which is option B. If y equals x raised to the power 6 minus 1, find the range for which y equals 0. Okay, in solving this will become x bracket x raised to the power 6 minus 1 equals 0. Since they said our y equals 0. Now, this has already been factorized for us. So we can say x equals 0. That's one of our factors. And x raised to the power 6 minus 1 equals 0. So that means x raised to the power 6 equals 1. That's another factor. But now, if we have x raised to the power 6, okay, be it either positive or negative, we are still going to have a positive 1. So our range of values will become from minus 1, 0 to 1, okay, which satisfies our answer as option C. End of today's tutorials. If there will be any question, put it down in the comment section below. Don't forget to subscribe, like, and click on your notification buttons to get more updates.